Hello guys and welcome at my channel. In the last video we solved second order differential equation which was homogeneous. Y second prime minus 5y prime plus 6y equals to 0, as you can see right now. Today we're gonna go step further and we would like to solve, well, a similar kind of equation, but now this is non-homogeneous. So what will happen here? Well, the approach is we have the so-called complementary solution, which is already given in the previous video. Basically, we were solving a quadratic equation, corresponding quadratic equation, and now we are looking for the so-called particular solution, which means, well, in this case, this is a quadratic function. So our approach is to figure out a particular solution of this equation of the kind ax squared plus bx plus c. Why are we doing so? Well, we see this is the second degree. This is the second degree equation, and if we are now just putting the derivatives, so yp prime would be 2ax plus b, and yp second prime would be just 2a. Now let's see, we will just bring those three in on the left hand side of the given equation, and we would like to get the right hand side at the end. So let's see, y second prime, what was that? Well, as you can see, it was 2a, right? Minus 5 times y prime. What is y prime? Well, you can see it here. This is 2ax plus b plus 6y. So 6, and what is y? Well, this is our particular solution, ax squared plus bx plus c. So this is the left-hand side. What is the right-hand side right now? Well, it's going to be 3x squared minus 5x plus 7, as you can see it right here. What we have to do now, we have to multiply out the left-hand side. We have to combine the factors, and then we compare the factors, the coefficients on the left-hand side and on the right-hand side. That makes sense. I mean, if we have one single expression on the left-hand side with x squared, and the left-hand side and the right-hand side must be equal, then obviously the coefficient in front of x squared on the left and on the right must be the same. The same for x, the same for the absolute values as well. So let's be careful and let's do it here. So I have 2a minus 10ax. So 2a minus 10ax. Now we have minus 5b plus 6ax squared plus 6ax squared, which we have still on the left-hand side, plus 6bx plus 6c, plus 6bx plus 6c, as you can see it right here. On the right-hand side, we got 3x squared minus 5x plus 7, 3x squared minus 5x plus 7. Now, can we simplify the left-hand side? Well, let's bring maybe the highest power on the front. So we have 6ax squared. What do we have with x? Well, we have 10ax and 6bx. So I'm taking x out. I'm having 6b minus 10a. And then we have only absolute values remaining. So these are 2a minus 5b plus 6c, and this is 3x squared minus 5x plus 7. And now you see what we're doing. We're saying, well, since those two must be equal, once again, the coefficients in front of x squared on the left-hand side and on the right-hand side must be the same. So 6a is equal to 3, firstly. Secondly, 6b minus 10a must be equal to minus 5, and 2a minus 5b plus 6c is equal to just 7. So this is a system of linear equations, but this is actually straightforward because you see from the first equation on the top we can solve it, and we have a equals to a half Knowing this, we substitute the value of a, which is equal to a half, on the left-hand side. So we're going to have 6b. Now look at this, minus 10a, minus 10 times a half is minus 5. On the right-hand side, we have minus 5 as well. So 6b is equal to 0. That means that b is equal to 0. And now we have 2a, which is 2 times a half, which is 1. b was 0, plus 6c equals to 7. We bring 1 to the right-hand side. We're going to get 6c equals to 1, and to 6, sorry. And that means c is equal to 1. So this is the solution. So that means our particular solution was f of x equals to a half x squared. Once again, b is 0, and c, as you can see it right here, is equal to 1. So a half x squared plus 1. So what is the conclusion? We wanted to solve y second prime minus 5y prime plus 6y equals 2. Let's have a look. Correct? Yeah, it seems to be correct. 3x squared minus 5x plus 7. I just invented it. 3x squared minus 5x plus 7. And, well, we know now that the complementary solution was already given in the previous video. So we have y complementary plus y particular. This is our total solution. And what would that be? So this was c1 times e to the power of 2x plus c2 times e to the power of 3x. And now the idea is the same. We are expanding our solutional space, and we are also adding a polynomial solution, which brings us not 0, but exactly this wanted result, 3x squared minus 5x plus 7. So we are having then plus a half x squared here, and on the right hand side plus 1 as well. So that's it. Basically, you see it's the same as solving the linear equation of the first degree, what we've been doing previously, but well, it's a bit, maybe we added a bit more steps. So we have like quadratic equation in order to solve this. Now system of linear equations as well. It can get harder, but the main idea remains the same. So I hope you guys learned something, at least as I was sitting in my lectures for the first time, listening to the lectures of differential equations. I was a bit lost because I didn't understand the idea of that. I hope it was clear, or it became clear at least. And well, this concludes my first part of differential equations. And I'm gonna do further lectures about differential equations, but not right now. Maybe we're going to talk about, I don't know, continuity, some properties of the e function, some properties of integrals and trigonometry, something like that. Okay, thanks you guys for watching. See you in the next video. Bye bye.